an optimized phase control Metasurface-based low profile folded transmitter antenna. Now, transmitter antenna high gain, it has a large focal ratio resulting bulkhead assembly. For the satellite and other wireless communication require low F by D ratios. Folded transmit antenna suitable solution where the figure may define as profile height, 1 dB, 3 dB dBWs, overall gain, aperture efficiency, and side lobe levels. However, all those high FTA are limited by aperture efficiency, narrow 1 dB, 3 dB dBWs together with high side lobe levels. For designing a folded transmitter antenna, first we design a transmit array which has a fabricated resonator, which cross-polar amplitude is more than 80% and its unit shell varies linearly over the frequency. Then we design a reflect array which has a also cross-polar amplitude more than 80%. Now we design a wide band differential feed which has a stable beam width over the frequency band. Now, as you can see that as the frequency increase, the phase profile gets denser and denser, and we require a unified phase profile who should not vary with the frequency. So that's why we have to introduce the PSA optimization, where first we optimize the feed positions with the TA aperture maximal interceptor. Then they modified the phase element with the feed, including the feeder element. Then we calculate the overall phase, and then we calculate the overall directivity of the folded transmitter antennas. And we put a cost function. If the cost function will give the desired performance, then it will stop. Otherwise, it will be go the step one. Here is a sampling of 45 degree of our desired phase profile. Here is the folded transmitter antenna where the top one is a transmitter array and the bottom one is a reflector array, and here is the feed. Now here is the return loss and gain performance. Return loss is more than 12 dB, more than 10 dB throughout the frequency band in the operations. And here is the peak realized gain along with the frequency is shown. The maximum aperture efficiency is 42% is achieved. Here ABC is the radiation pattern in 12, 15, and 18 gigahertz. And D is showing the side lobe levels of XOZ and YOZ plane. And it is seen that the 18 dB, more than 18 dB in the side lobe level throughout our operational band. And here is the figure of merit of our transmit array antennas. You can see that the H by D ratio is 0.113 and the aperture efficiency is 42% together with the 1 dB and 3 dB dBWs of 28 and 54%. Thank you. Thank you for listening.